Okay. Right. So, few more minutes before Easter, and then you are all. I think it's your last lecture today. No, perhaps. Yes. Okay. No, it's not. Okay. The 30 years are
next week.
All right. Well, that was the. What am I missing here? Is it or is it not next week?
When next week?
Next week is break. So there's 2 weeks break, right? So in terms of lectures, right? 2 weeks break in terms of lectures, right?
Yeah. So that's the last one. Sorry, it was me.
Yeah, no, it's only 1 week pause in lectures.
I think it's 2, at least on the schedule. Yes.
No, it's 1 week, and then there's the Tuesday and Monday after that.
All right.
I see.
Tuesday as well.
Ah, okay. That's why pretty much all the lectures are crossed out. Okay. Anyway. Yeah. So
Tuesday is Tuesday. No, Tuesday's Friday.
Anyway, we'll check all our schedule again and then figure it out.
Every day is Friday.
Okay.
Yes.
Right. So we're not quite in Easter yet. So let's give us those last 5 minutes to actually do something. So the idea is that yes, unit tests in Java. So it's pretty much the Java standard for unit tests. If you learn it here, you know how to do it in Java. And that's quite helpful to know. And the idea is super straightforward. You need to think about how do I isolate the environment for a functional unit enough that it can actually that I can perform its test, right? So you minimize the environment. So and the idea is after specifying the environment, you create some tests that does some takes some input and produces some output, and then you basically evaluate that against we evaluate the output as it's produced, and and so on. So you have a large number of those different test cases, or tests that are combined in one test class, and many classes can be combined in test cases that can be run comprehensively. If you use Android functionality, it will be dynamically replaced by a mocked version, basically that behaves like Android but is not Android, at least in the unit test case. And the neat part as well, you get some kind of reasonably useful outputs as part of the Android Studio environment, which is facilitated by Gradle in this case. So just let's build some simple tests. We'll see how it goes. Here's an example activity, and you won't guess, I was incredibly creative. I decided not to build it from scratch because that would take too much time right now, and secondly my machine is not too punchy either, but I want to share you the intuition of the application. If it comes up, it will eventually. Point is, it basically is a simple, very straightforward calculator idea, the classical standard test environment that is useful. So you have some sort of two input values. You have functionality to do addition, subtraction, and possibly multiplication, division. In which case I just concentrate on addition, subtraction, and the question is now, okay, how can we make this application testable in the first place, and then how do we write simple unit tests for it? Because once you see how it's done, it's actually kind of straightforward and feasible to do it for any other problem. Let's see. Patience. Yes. Yeah, I probably need to look into getting some other machine here. Alright, well, I'll just reiterate over, even though we can't see the UI yet, the idea is one single activity. We have an edit text, two edit text fields, we have two buttons, we have some sort of output text view that produces, shows us the response, the result of the operation. Those are initialized upon create. So here you see in the create, we have different fields that are linked to those objects then. And we attach individual listeners to individual buttons, right? So we have button add in this case, and we have a button sub. And the only thing they basically do is perform an operation, either an add operation or operation. Oh God. Oops. Let's see. Strong APKs. Oh, seriously. Yeah. So, of course, that's the fate of the presenter. Try it again. In worst case, I need to wipe the device. So, and what's happening in the perform operation down here? The idea is quite straightforward. We have do I need to run that dry really? Well, we probably. So we're parsing the content from the first text field and the content from the second text field. Perhaps we can at least render them here. Yeah, there's something coming up. Cool. So first text field, second text field, output field, add button, and down there is the subtract button. And that obviously would provide the nested functionality. The idea is for the addition, we just take input value 1 plus input value 2, present it back to the output. Quite straightforward. For subtraction, do it differently. And we just basically switch on the operations that the user pressed. Yeah, so quite straightforward, no magic there. Cool. And the first thing is now, if you want to make the testable, particularly the elementary functionality of addition and subtraction, what would be the first thing we should probably do if we want to focus on functionality? Right now is one coherent activity. Any ideas? Not right, no. Just speak up while I'm trying to debug this here. Yep.
Just write a test to run the perform operation function.
Yeah.
And expect the value.
Yep. Cool. Exactly. So we would do exactly that one. I think I need to wipe my device. It's unbelievable. It worked last night. Yes, that's precisely what we plan to do. I'll just wipe the device and just hope that it will work then.
And then you have to mock somehow the input fields.
Yep, we get to that. Well, perhaps we get. That's right. So, so my suggestion, as a modification of yours, you said mock the input fields, but then we doing two things already. Then we're suddenly involving UI components already, while at the same time looking at functionality only, right?
But in this function, you actually can only choose the operation, but not the inputs.
Yep. So what would you think we should do?
Or maybe extract the functions from the perform operation to something that takes all needed parameters.
Yeah. So you basically externalize functionality, right? By separating.
Refactor perform operation into operations methods that are not that don't rely on the input, just on the parameters.
That's right. Exactly.
Test those.
Exactly. So yeah. So by externalizing them into separate method, for example, right? That's number one you want to perform. So let's see if we can do that quickly enough here. So we just return value 1 plus value 2. Exactly. So that's one way. We have the subtract thing as well. That's right. Yes, I could do that as well. It's one other way of doing it. That's right. But for the sake of simplicity, what could we do? I don't know, keep an instance of the calculator somewhat handy and then use that one. And how do we write a unit test? Simple, straightforward for that. for the ones that have experience with unit tests. Just say it out loud if you like. No opinions? Okay. Alright, I'm alone then. Alright, we'll do it. Sorry? What am I missing? I have a missing bracket I need to get rid of here. Make it a bit more consumable. That one and very different perspective from here.
You need to cast it back to string.
No. Ah, for text back. That's right. That's right. Thank you very much. That's right. String value of either. Yes. Cool. So the main thing then is the isolation of the test. So if you want to write tests, you will find those two folders here. One is called, well, with the tag Android test, and the other one is simply called test, and they refer to, one of them is the instrumentation tests that are meant, for example, for UI tests, and then the simple tests that are just used for individual unit tests. So if we want to do, for example, the calculator tests, quite straightforward, just set that up. We need to tell the system whom to what to run it with, and JUnit 4 runner, I think, just class simply. Yep, cool, cheers. And then yeah, implement a few methods. One of them would be public void setup that basically specifies the environment. So you here use Java annotations to specify the role of the particular method in the framework, and then you just run the individual tests. So addition, for example, and then sort of so you specify obviously a test case with fixed values. And we need to assign a result to that one. Let's use the object type. This and cool. We need to make that a test, so we use the test annotation for that purpose. And finally, we need to make assessment. And for this purpose, there's the group of assert functionality that's available equals can't resolve as it asserts. I'm in the test one here. Let's see if I have the imports right.
What's with this?
Test implementation is JUnit 4. Unit 4, that will be about right. Import statics. I want to use the assert equals from that framework, and text addition. So that's a text that will be printed in case of things don't work out expected. So what the value we're expecting would be 29, for example, here, and we just compared with the input value we're getting. It may complain because it is an ambiguous type. Ah. Yeah, need to be explicit. Double. Okay, so that would be a very simple basic test. So you basically isolate the calculator and then you do perform some operation, and then you assess the operation with respect to its result, and you annotate this whole thing with a test annotation. If you run this in Android Studio, it's actually building, it takes a while. Then you'll just get the response, and if it of course goes sideways, you get a corresponding error, and you can explore that further. So in this case, it will just tell you that what the divergent values were and the message associated with this. Note that those assert equals methods are all static as part of the JUnit framework, and they come in different variants for different different data object types or primitive types as well, and they usually come with a variant with and without messages. So many people just don't provide messages for their individual tests. And in addition to asserting equality, you can also assert that something is not equal, or that an array equals or does not equal something else. Or you assert a Boolean condition that is false or true, so that's something you can do as well. So it's quite rich. Assert null, yep. And sometimes you also, in case you want to have a controlled, indicate a controlled failure of a test. For example, you're running a test that produces a exception, right? So for example, some sort of casting exception. Instead of testing explicitly against this arrow, you can just call the fail function that will just fail the entire test, and you put a message in there indicating what actually went wrong.
Do you have like a tear down annotation?
Yep.
As well?
Yep. That's the that's right. So in this case we didn't do that, but you're right, for comprehensive environment specification you would also have I think it's the after annotation in this case that you would use to indicate, okay, now you can reset, destroy the environment. It's good for if you want to test databases, for example. So into set my project back here. Cool. Okay, so that's one of the basic functionalities. So a variant of that one, sometimes, especially if you're dealing with variable input values, right? Such calculator case or similar calculations of that nature, you don't just want to only test one value, right? So you could. So what could we do to deal with this issue? Right now we tested one simple value combination of 2 and 27, which is apparently wrong. So what's the pathways we could go down? Test negative values, right? Exactly. Identify boundary cases. Yes. What else? Yep. Test with strings. That said, you will probably get issues that. Yeah. Okay. Yeah. You could do that. That's right. Agreed. Cool. Other ideas? You did all that before, right? So quite straightforward. So, but the idea is, yes, generally you have different input, right, or multiple input combinations that you want to test as. And for this purpose, you can do a parameterized test where you basically reuse the functionality and just modify the input values for each iteration of the test. So it's a lot easier than typing all those combinations out, which you can do, of course. So, but we plan to avoid that. I've copied the entire class. It wasn't super clever, but we'll survive. So, good. So in this case, we have a slightly different runner class, which is called parameterize.class. So it's quite useful as well. And the only thing you need to do is to basically specify a constructor that has a signature for parameters you want to pass into the test. And let's say if you have a parameterized, should have picked something shorter. Good. You just specify the signature, for example, double first, double second, and double result. And then you kind of need to assign it to local variables as well. I'll just type it out here. Double second, private, double result. Peter, please join us.
Look at that.
We're doing unit tests.
Unit test.
Yes, exactly. Do we?
Okay.
Yep.
I think there's a okay.
Is the class going on here?
Double booking.
Oh, really?
Perhaps.
Possibly.
Possibly.
Are we in the right room, guys?
But I can talk to the students outside.
How many are there?
No. We can talk about minutes. No, it was just a sum up before they had the exam. So that's their stuff, you know, the people are sitting outside.
All right, cool.
But that's okay. So we were in here in the morning, and then I think it's also until quarter past or 2 o'clock. But that's fine. I think we can be flexible.
Yeah.
And talk to them outside. But then they might disturb once again.
Okay. So how many
minutes?
Yes, 15 minutes. Okay, we'll wrap up
Track
quickly.
their stuff, you know. But
That's fine. That's fine either way. We can probably. I can probably try to wrap up in 15 minutes or something. Like
That's
that.
okay.
Yeah. Thank you.
Wrap up outside.
Thank you. I appreciate it. Thank you very much.
No, we're just talking.
So, okay. So, but we are in the right room, right? Per scheduling? Good. Okay. So, cool. So, just that one. And then you can basically specify a set of input parameters. For example, using a static method or static field rather. So build app and object types of choice. I think we get away with a generic one today, and it can have any name of your liking, and yeah, I have basically just an array of individual components. So object, and we do inline specification of those. I don't know, and then basically you have your I don't know, null plus null is 0, and so on. I don't want to push that too far right now. I think 2 plus minus 1 is minus 1, hopefully, and so on. Cool. So what am I missing? Of course, there's some bracketing thing that I probably got wrong. We have an array and an array. We need to indicate this as well. So you can basically specify a large number of parameters of your choice. The key thing is, again, is most of the time if you get something wrong, it doesn't work, it probably you have probably forgotten the annotation. So realistically, because it doesn't really matter what it's named, as long as there's the annotation, you'll be fine using it. And in the test functionality, you just then basically, instead of using fixed values, you just make use of the variables that are fields we have specified earlier. Second, and the result should then correspond to result. Let's see. That's invert.
So this is similar to table driven, like we did in, like some of us did in cloud.
Ah, right. Okay. Yep. That's actually, you're spot on. In fact, it's exactly the same as in cloud. That's right. We did it there using the built-in test environment from Go, right, from Golang, and it's emulating the idea of unit tests in Java quite immediately. That's right. So you're very comfortable with that idea. But anyway, so those are possible pathways you can go down. You write your simple tests, or many of them, like ideal with a high level of coverage. And then yeah, explore that. So hang on, I think you can also, let me just check, assess the code coverage of your tests if you run them with coverage. Just do, so you actually get some meaningful output as well. Yep. So here this shows you the code coverage of your tests, unit tests for the entire all packages, and you obviously need to navigate down to see actually what you covered. And you see here, so for example, our test now covers calculator, surprise, surprise, 200% the class and 50% of the methods, which is one of two because we didn't test the subtract one yet. So it's a quite neat way of also identifying coverage. So you can do that here as well. But the thing I actually wanted to battery is running low. Cool. Luckily, sorry stream people, being on stream doesn't only have advantages. So the other aspect is the UI testing that we can briefly explore. Given that my emulator still doesn't want to do its job, see, perhaps it behaves a bit better now. That's the other thing. So basically that's unit tests, so you can write them yourself, quite straightforward. Looking at instrumented tests, they in principle also run, nope, that won't work. Is in principle also straightforward, and that uses the Espresso framework. I'm not sure if I did the import correctly. Right, yeah, so yeah, we don't see much right now. That's a bit of a pity. So what we need to know is some of the elements. We know them from the main activity, so we have text values, buttons, and some output that we want to deal with. So we need to use those in our test. So it can test the app context. Fine with me. We have another test which no, we can just continue there. And the idea now is that we no, do it separate. We use the Espresso framework to interact with the UI. So, and how it works is basically, yes, you have another method, of course. And test output can be named anything as long as we get the annotation right. So And Espresso, a framework I mentioned before, hang on. Provides us with the on-view functionality. So let me just see if it for once finds. Yep, it does. Cool. You can identify elements by ID in the view elements by ID, which is quite handy because that allows us to do GUI testing without knowing the coordinates or the exact GUI, because you can basically just use the usual identifiers that we are comfortable with. So text val1, for example, and then you can perform activity on it, and those are quite numerous. One of them is type text. Cool. And then you produce some input value, I don't know. So and then for the second one, I don't know. And finally, it evaluate this whole thing. So with id dot id btn add right, and then you can also perform other operations such as the click, of course. Hang on. Right, and then you obviously want to do the match on the last item, which would be the output, TV output. And there's check functionality, and then you can do various things, including match some output. So in this case, probably 20. So I forgot those ones. So that would be your test in using Espresso framework. So I'll just run this thing. I don't know, perhaps get something going here, but I don't have high hopes. Point is, this will actually run the phone. So the first part, the unit tests, the ones we ran before, they're just testing using JVM locally. So you actually don't need to have a device attached to them, but the UI tests actually need to, in order to test the functionality. And you can actually directly follow the functionality execution as well. All right, yes, I forgot something here, which is you need to specify the activity you want to launch first, because I just did the execution of the test, but I didn't specify the context. That's my bad, so perhaps we're getting a bit further, but I think it was just a activity test rule for, and now we address the activity name, which is main activity. Activity rule and we pass the activity class main activity, of course. So good. Need to import that. Activity test rule, what am I missing? Looks good to me. See if I got it wrong. Ah, typo. Thank you. Go. All right. So let's try that again. this time we have everything. It actually does it. Cool. So, what you saw now? So you saw it's typing briefly, right? So, but you saw there's an arrow coming out, and the issue after dealing with this. So that one of the problems is that those UI frames are a bit more fragile. They really depend on device performance. They are timing dependent. So in many cases, you need to think about introducing some sort of wait time before doing the next interaction with the UI, because the system is simply not done with its previous interaction. But one of the issues that I most commonly found is you need to close the soft keyboard before getting access to the actual activity again, because the soft keyboard will obscure the actual activity and then make the ID not addressable in your activity. So if you close the keyboard in this particular case, I think you should be fine, performance okay. But this is another reason why unit tests kind of should be separated, because they are a lot more reliable than those ones here that we run directly on physical devices. It actually does it. So obviously it's something else wrong here, which is
20.0 instead of 20. Check results.
Chuck. Thanks. Brilliant. Yep, that's right. So that's the message here as well. It's usually reasonably explicit in the output. Cool. So at least that kind of worked. Yeah. So that's the other kind of test you want to do. So that would be one of the UI tests you could use. So Espresso is the framework of choice here. You will just need to specify the activity you actually want to run it on, and then run one or more tests and performing this interaction. So you can match on the IDs. You can also match on label names if that's easier. Sometimes you may not have access to IDs, but IDs is the most reliable one. One recommendation is if you do matching on particular views, don't use multiple tests. Don't test on an ID and the name of the label, because it's kind of resource quite expensive to do that and may slow down your tests even more. So find the most precise identifier you can get for any input element and use that one to interact with the environment. Yeah, so that would be one way of basically writing a simple test. Of course, you can extend it and also interact with the context menu. I think I have some examples in the slide set that highlight this one. Yes, so in Espresso, basically the fundamental things you want to use is matching of particular components based on ID or based on text or data. So you can also test on data output. For example, if you have a spinner and you can only see data, you can match on that. And you can perform activities such as focusing on a particular view, pressing the back button, emulating this one, or closing the soft keyboard and things like that, right? So something you can do out of the box. And then in addition to the matching and the actions you can do, you can perform actions on the particular elements, such as perform action, the click action, things like that, right? Or long press. And of course, we also need assertions. So in contrast to JUnit, where assertions are always indicated by assert, assertions are here indicated by check. So it's a check on some sort of value, for example, in the output form that you see. So yeah, so that's the general pattern. You just saw it before. We have an identified view, we do something on it, and then we match something against it. Cool. So yeah, special cases, selecting item in the spinner. Yeah, that would be something that's worthwhile doing. But you'll find a lot of recipes on this in this URL. I'll upload the slide set later, because it explains how you can basically pick any kind of, or nearly any kind of Android component you can interact with. Mind you, test it on your virtual devices. In my experience, there's always some glitches, or often some glitches with respect. They boil down to performance. So you may need to introduce some, I don't know, sleep thread, few thread sleep statements or something like this to actually slow down the interaction, or check if there's nothing else installed that will interfere with the activity test you're doing. So for spinner, for example, you would select the item with the spinner ID and perform a click on it. Then you would look for data that match a particular selection test, selection text in this particular example in the spinner, and then perform a click. So you selected the actual item, and then you can do your check on that one. So you again select the spinner and then check whether a particular item that has been selected now contains the given selection text. Yeah, so that would be a typical way of doing this one. Or open a context menu. That's getting a bit more involved. You kind of need to open the options menu for the instrumentation target context. So instrumentation is the application, the test framework Espresso that is embedded in the activity and basically listens or is matched to the particular activity functionality. So yeah, but check for the recipes, it's quite worthwhile exploring. Something I just wanted to point to is, which is pretty cool that Google offers it now. They call it the Firebase Test Lab for Android. And I just bring up the UI. So you can actually run your applications when you want to release them, or before release ideally, on actual physical devices, but you actually don't need to do it yourself. Instead, you just use their infrastructure to do it. So Android provides this test lab that allows you to test your applications on show it to you on physical devices. So basically they host a set of devices such as those ones, oftentimes with older ones as well, and you basically mix and match. You set up your tests, so select the devices, deploy your application, and they will run it and provide you with reports of the test results in their test lab environment. So quite interesting idea there. So, and it would be something like that. So basically running a test, and that gives you indication about runtime, the orientation you can test as well. So you can specify orientation, you can specify the locale of the phone as well. So whether you want to have English or some other language, and it spits out whether it actually works or what possible issues occurred during the test. So it's quite powerful. And it basically does the similar thing to what we did. It emulates the user interaction with the application and uses that to assess whether your test actually works. You also get the full logs and so on. So it's actually quite powerful to bear in mind if you are thinking about releasing your app seriously. Then it's a good way of interacting with it. What you can also do is to integrate it with your continuous integration environment. So instead of just uploading your app there and having it run, you can integrate it into your build process. So automatically submit it. And and see what the results are. Another feature is quite neat is the screenshot. So you can actually look by screenshot what actually happens. So which is I think quite helpful if you have that, if you want to debug your issues further and figure out why things actually didn't quite the way you expected it to go. Yeah. So and you can use G-Cloud, so the Google Cloud API to interact with this as well. So it's quite neat idea, I think, to complement the testing, particularly when you're thinking about releasing your application to a wider audience with the that is challenged by Android device fragmentation. Few words about RoboElectric before we're done. I just show the framework to you, and you find it's fairly similar to what we saw just before. So instead of having JUnit 4 as a test runner, you are just using RoboElectric and having it interact with your UI. The idea is there, it doesn't rely on a virtual device, but just does everything in an emulated version of the Android environment. That's basically it. So it's quite a bit less timing dependent compared to Espresso, for example. So it's another low-key alternative you could use. Cool. All right. So that's it from my side. I recommend you, if you want to watch the Google talk on test-driven development from Google I/O 2017. It's worthwhile watching. And for Espresso, especially the basics and recipes, have a look under this URL if you want to use it in your testing for all different UI components and so on. So because otherwise it's a bit tedious to figure that out on your own. Bear timing in mind, that's my hint. Bear timing in mind and see what the interaction actually does. That's the easiest way of debugging why Espresso doesn't operate the way you expect it to do. Yeah. So as you guys just figured out, so it's quite helpful. Thoughts, questions, or experience with any of those? Especially the JUnit fraction in the back, perhaps you have experience to share with the others? No? Anything I need to bear in mind? Yep.
If you need to test for a specific exception, you can add it as an expectation to the test annotation.
Sorry, I didn't get it.
If you are expecting a special or one certain exception, you
Yeah.
can add it to the test annotation as an expected.
Ah, right, that's right. That's a good point. Yes, yes, yes. What was the annotation again?
The test annotation, you can add a parameter that's called expected, I guess.
Yeah, let's see.
On the app test. Just, that was like parentheses,
Parentheses.
and then expected.
Expected.
And then you pass in the class.
Right,
the
right.
exception.
Okay. Right, so if you, yeah, it's
Lowercase. All lowercase. So expected equals the exception of class.
That. Cool. Of course, don't capture exception because super generic, be as precise as possible. So if you know the exception, because by running the test and see what went sideways, use that one, right? Because exception is a bit too general. You want to generally be more. That's a good point. Very good point. Yeah. So yeah, but there's an abundance on documentation of JUnit out there because it's been around for ages, for 10 or more, 15 years or something, and exists in various versions. But version 4 is still the mainstream one, whereas the version 5 and 3. Avoid 3, but yeah, use those for your testing of your functionality. Do it often early. I mean, it's quite simple, very straightforward. In this way, you can actually harden your application while you're working on it. So, yep, that's basically it. Any other thoughts? Yep.
Or maybe it's important when scheduling somehow how the tests are run dependent on each other, that you should not start the test before the previous is done.
Yeah.
So probably, I don't know if it's in the Android Studio, but using some kind of a test suite for to gather tests together.
That's right.
Then you would be run it after each other, not if it takes a little bit long time for one test, for example.
Yeah.
I just done some research on this, and JUnit does not support dependent tests.
That's not it.
So you can specify that specifically.
It's generally, yeah.
Yeah, JUnit says that it's not certain which order the tests are run, because unit tests are supposed to be individual.
Yeah.
Yeah.
And they randomize the execution as well, right?
Not necessarily.
No? Okay.
You can't guarantee the order.
Okay.
So I guess it's multi-threader or something.
Yeah. But yeah, in this case, but what you could do is write more coarse-grained tests, basically, right? So that subsume some of the functionality, right? So, but yeah, it's a good point. So yeah. But again, that's where the testing hierarchy comes into play as well, because if you can solve that issue by running, for example, UI tests, right, that assumes that sequence, then that would be one way of mitigating those problems, right? Because you imply order of execution. Yeah, okay. Anything else? No? Yes?
Would you say espresso is a mock of the usage?
yeah, pretty much, yes. I mean, yes, if you have that, that's right. So it's a kind of behavior injection, basically. Yes, from a user perspective. So not from the bottom, but rather from the top. You basically, yeah. It's just an UI interaction framework. There's, I think for HTML, I know there's one HTML unit, right? But you have a comment?
Just a question, actually.
Okay.
You know if espresso supports Amcrest matchups?
Yes, yes. You can integrate with Hemcrest. In fact, yeah, Hemcrest is one of the popular libraries for any sort of matching that's done as well. Yes, that's right. Yeah, yeah. I think you find it in some of the recipes used as well for more complex matching aspects, especially if it involves regular expressions. But yeah, so that's kind of the opposite of the mock. We didn't talk about mocking, but you can explore it as well if needed. But probably most likely you get away with using some sort of UI test and unit testing for your sake. It's worthwhile just trying it out and see how it goes, even if your problem is relatively simple, just to get a feel. But yeah, so yeah, I'm happy that it actually worked eventually, that the device interaction. But yeah, that's the idea. Important thing, just as a gotcha, is ensure that you get the dependencies right. So, for example, if you want to use Espresso, ensure that it's attached to Android test implementation, which would be the instrumentation tests. If you just say test implementation here, it will only be available in unit tests, which it may not, which it's not used in, for example, right? So you will not find the dependency and wondering, okay, why can't I use Espresso in this one? So you need to be explicit whether you're doing unit tests or instrumentation tests, and then the primitive here changes. So yeah, but generally it should be implementation, test implementation, and Android test implementation. It's the most common one. In older versions of Gradle, you find things like compile or runtime folio APK and so on. They have changed in Gradle 3 onwards, so you can use both, but it will tell you that a compile statement instead of implementation, for example, would be deprecated. We'll see if my environment actually does that, but it's technically still okay. And in many, if you look for resources, yeah, I think that's the one you get here. If you look for resources, many times the build.gradle file still uses the compile statement, which simply means that it's the older variant. But you should use implementation if you can. Yeah, but we talked about that yesterday. Cool.